introduction of cryptography. We can provide a whole bunch of security services, but only a few of those, like 4 of them, can be actually provided through cryptography. They are important ones, so we want to understand them. We will try to develop a thorough understanding of what each type of cryptographic algorithm we have to deal with. At the moment, we have these 4 different type of algorithms available to us. So number 1 is the symmetric key encryption algorithm, public key encryption algorithm, hash algorithms, and random number generators. So there are 4 algorithms in 4 different colors, and these coloring schemes are important because they will continue throughout the book. So whenever we deal with random, it will be random, it will be red. Whenever we deal with public key cryptography, it will be purple. Okay. Symmetric key encryption is also sometimes called shared key algorithm. Public key encryption algorithm is sometimes called asymmetric key algorithm. The hashes are also sometimes called fingerprints, cryptographic checksum, digital digest algorithm, one-way function. There is another variation of hashes. It is called HMAC. Those are the 4 basic types. Now we can look at their organization, hierarchical classification of them. In this picture, you can see that on the top we have cryptographic algorithms. We can broadly categorize it 3 different categories. On the left, you see a random number generator. Then we have the encryption-decryption algorithm. Finally, we have the hash. Encryption-decryption can be further classified into 2 categories: the symmetric key algorithm and the public key algorithm. In the symmetric key, both the keys on the encryption and decryption side are the same. And if they are not the same, at least they can be deduced. So you can calculate one from the other. Essentially, if you have one key, you know what the other key is also. In the public key algorithm, that's not the case. So decryption key is different from the encryption key, and it cannot be calculated. It cannot be deduced from the encryption key, and vice versa. So from encryption key, you cannot deduce decryption key. There is a sub-classification of hash which is called HMAC, or message authentication code. In other words, hash-based message authentication code. So these are like 4 classifications. Now what we are doing is we'll dig into each of these algorithms in more detail. So before we do that, this is a general top-level view of all cryptographic algorithms. How many boxes do you see here? 4. So some of these things will be missing. The middle box will never be missing, of course, because that represents the algorithm itself. But the algorithm may not have a key. It may not have an input. It may not have an output. Okay. A generic picture of encryption algorithms, or sometimes they are called ciphers. This picture gives you the basic terminology. On the left, you have the plain text. As you see, this is our reference. Remember, this is a generic representation. If you compare that with this, you're good. It's exactly the same picture. Also, this one here, except for the input is a ciphertext, which is the input data here, and the output is plain text, which is the output data here. And this is the key, which is the key here. So sender takes the plain text, encrypts it using what is called encryption algorithm or cipher. Using an encryption key, produces a ciphertext. That ciphertext on the receiver side will be decrypted or deciphered using a decryption key, and it will produce a plain text. This green line here represents the channel. Now it's going from one place to another place. So here is the notation for encryption decryption algorithm. So we have the plain text, which is represented by P, the E operator and the D operator, E for encryption and the D for decryption. And then we use the superscripts and subscripts. So K is for the key. So you will have receivers, this KER, receivers encryption key, receivers decryption key, and so on. If you want to do cipher, you have C is equal to, you're using the R key, right? The receiver's encryption key, plain text. And here we are using the same key here, so the subscript remains the same. You take the input is the C and the output is the plain text. Here the input was plain text and the output was ciphertext. So this is a closed form mathematical representation of the same processes I showed you in the diagram. More precise representation of what I showed you here. The question is, how do the receiver and sender get access to the same key? Okay, I'm not going to answer that just now. So that's actually a problem in itself. And the area is called key management. So how do you get the key when you go to a hotel, a motel? So in the old days, they used to have this closet and they would go and pick out the key from there and give you the key. Now they have the machine that they create a key right there in real time from the magnetic cards. It's key management.